first, I'm going to remind you the concept of a function. A function f is a rule that assigns to each element of a first set, and this first set of the inputs are called the domain of the function. So a function will be a rule that assigns to each of the elements of this domain a unique element that we call the output. This element will be elements of another set. It could be the same set, by the way, that we call the codomain. So this is a function, actually a rule. So we're going to have, for having a function, we are going to have a rule, a first set that we call domain, and a second set that we call codomain. Or we can say a rule, a first set of inputs, and another set of outputs. So if the inputs are pairs, and I'm going to say ordered pairs, when I say ordered pairs, it means that this pair have a first element and a second element. So it will be clear what will be the same and what will be the second element. When I say they are ordered, it means that there is a first and a second. So when we have that the input are pairs, not only one element, but a pairs of elements, and this pair of elements is ordered, then we have a function of two variables. So for example, if this is a pair x, y, so the image of a pair under the function f is a number z, then we can write f of x, y equals z. So the meaning of this is the same of this. So to say that the image of the pair xy is z under the function f means that f of xy equals z. And we're going to be using this symbol. So remember, when we are speaking about only one variable, we say f of x equal y, for example. In this case, we are going to have f of a pair equal another number z. So we are going to be speaking about numbers. Here the functions will be about numbers. Obviously, a function could be any other thing. But here in this course, we're going to be speaking about pair of numbers, and the answer here will be a number. The output will be a number. I'm going to say that the pair xy is the input and z is the output. We are going to use this notation, f of xy equals z, to define the assignment rule of the function. So I'm going to say things like this. The image of xy equal x plus y plus 5. So I'm using this notation to define the assignment rule. In this case, to get the image of a pair xy, we need to add together the first number. Now I'm going to say x. This is an ordered pair. And usually in mathematics, to denote that this is an ordered pair, we use this round bracket. So the thing that is inside is a pair, but not only a pair, is an ordered pair. So this x will be the same element, and this y will be the second element. So this xy is different than yx, for example. So it's clear which is the element, the first element, and it's clear what is the second element. And this rule is telling me that to get the image of a pair, I need to get the first element of the pair plus the second element and add 5. This x and y in this case could be whatever real number. So actually the domain here is the set of all pairs of real numbers. Or for example, I can say the image of a pair, it will be x squared minus 1 divided by y minus 1. What is the meaning of this? We are going to square the first element and then subtract 1 and divide the result by the second element minus 1. So this is again a rule of assignation and define a function. Here we notice that the second element cannot be 1, for example. So in this case, the domain cannot be all the real numbers. Because if the second element is 1, then we're going to have 1 minus 1, 0 at the bottom, and I cannot make the division. So the domain will be all pairs of real numbers in which the second element is different than 1. We noted that in this case, any pair whose second element is 1 cannot be an element of the domain of F. But what happened is we want to find g of minus 1, 2. So what is the image of this pair when the first element is negative 1 and the second element is 2? And they are telling you the rule of assignation. You need to get the first element, add the second element, and add 5 to the result. So actually what you need to do is just make a substitution of each value in the rule. So it will be -1 plus 2 plus 5. That will be the image of -1, 2. And then this will be -1 plus 2. This is 1 plus 5 equals 6. The image of a pair will be a real number. Let's see the other example. F of xy. What will be the image of 3, 3? Of this pair whose first element is 3 and the second element is 3. And I know that the only that I need to do is substitute x by 3 and y by 3. And I get that this is 3 squared minus 1 over 3 minus 1. You can use your calculator to do this. Yeah, this is 8 at the top, 9 minus 1, 8. 3 minus 1 is 2, so it will be 4. The image of the pair 3, 3 is the number 4. So now we notice that this function of two variables, because actually I'm speaking about two variables, will be functions that to each pair of real numbers we assign a number. Obviously, the number of inputs can be more than 2. We can assign a number to a triple of number. Or for example, we can do things like this. In this case, we have an ordered set of n numbers. Let's call it n-tuple of real numbers. So it means we can assign to this a number. We can say the image is x1 plus x2 minus x3 plus x4, etc. So anyway, we can have function of more than two variables. For example, if we have this, the image of the triple xyz equal x squared plus xz minus 6 divided by y minus z. What I'm telling you, that I need to choose the first element and square this first element. And then choose the first and multiply by the third, minus 6. And that gives me the numerator, and divided by the difference between the second and the third number. So in this case, we are getting a number. If we do that, we have a triple, but for this triple, we are assigning a number. This will be a function of three variables. And for example, if I need to find the image of this triple, 3, -1, 2, it will be 3 squared here, because the first element is 3, so it will be 3 squared. Then 3 multiplied by 2, because the third element is 2, minus 6, and divided by -1 minus 2. So let's do it. How much will it be? 3 squared, 3 times the last element, 2, minus 6 divided by -1 minus 2. This is 9, this is 6, this is minus 6, this 6 and minus 6 cancel. We have here 9 at the top and -3 at the bottom. This is 9 over -3, so it will be -3. So it means the image of this triple is -3. We have application problems. It costs $9 to produce a dozen of fruit-based popsicles and 14 to produce a dozen cream-based popsicles. Find the cost function in terms of the number of dozens of fruit-based popsicles and obviously number of cream-based popsicles. So in this case, I noticed that to know the cost, I need to know how many fruit-based popsicles I'm producing and how many cream-based popsicles I produce. But I know that producing a dozen of fruit-based popsicles, I spend $9. So if I'm producing X dozen of fruit-based popsicles, I need to multiply 9 times this X. And again here, if producing a dozen of cream-baked popsicles cost me $14, I need to multiply $14 by the number of dozen of cream-baked popsicles. So I notice that the cost function will be 9 times, so $9 times the number of dozen of fruit-based popsicles. And I need to add 14 times the number of dozen of cream-based popsicles. So in this case, we have a function of two variables. The cost is function of two variables. The number of fruit-based popsicles. So X will be the number of dozen of fruit-based popsicles, and Y that will be the number of cream-based popsicles. So this defines a function. And obviously, if I am defining this well, I need to tell people what is X, what is Y, and what is Z. This is the cost. Obviously, I can type also Z equal 9X plus 14Y. Z is the cost. So this is a practical application of the situation. Another practical application. If labor costs 150 per unit, and I'm going to call the number of units of labor, I'm going to call it X, and material costs 120 per unit, so the number of units of material, and capital costs $45 per unit. Imagine that we divide the capital in units, and each unit is $45. Write a function for total cost. Obviously, the total cost in the total cost involve, in this case, the labor, the material, and the capital cost. So I'm going to say that it will be 150 times the number of labor, 120 times the unit of material, and 45 times the number of units of capital that we are using. So this will be the function of cost. If we know the cost per unit of each of the things that we are using, we just multiply the cost of each of these units by the number of units and give me the total cost. So this is another example. How can we use a function of several variables? And actually, most of the functions of real life are of several variables. For producing one thing, we need several things. So we don't need only one thing. So for that reason, it's very common in real life to find a function of several variables. And this is multivariate calculus. It treats about functions of several variables.